In this lesson, we're going to solve trigonometric equations using different strategies, and some of the strategies come from the strategies that we learned when simplifying and verifying the trig identities. And a trigonometric equation is basically just an equation that contains a trigonometric expression with a variable. Let's look at example 1 and just ask the question. We know that sine x equals the square root of 2 over 2 is a trigonometric equation. And the question is x equals pi over 4 a solution? And so generally, to see if a value is a solution to an equation, you substitute. We would take the original equation and substitute the pi over 4 in for x, and the sine of pi over 4 is the square root of 2 over 2. And so when you substitute a value into an equation and the result is an identity, you have a solution. And then the question is x equals pi over 6 a solution? Well, if we have the sine of pi over 6, plug that in. I usually put a little question mark. The sine of pi over 6 is a half. 1/2 does not equal the square root of 2 over 2, so the answer to this is pi over 6 is not a solution. But the next question is, is x equals pi over 4 the only solution? You remember that trigonometric functions are cyclical. So in order to answer this question, before we actually go and solve a trig equation, let's look at the answer to this graphically. Now, in order to use your graphing calculator to solve an equation, we're going to go, now I'm in radian mode because we are dealing with radians, so if you're not in radian mode, you'd want to change that. And we're going to go into y equals, which is where we graph functions, and in y1 we're going to graph sine x, and in y2 we'll graph the square root of 2 over 2, and we'll see where they intersect, and that's another way to solve an equation. So we'll do sine of x. In y2 we're going to do second square root of 2. Again, some of you have to close the parentheses. I'm going to just arrow out of the square root symbol and then divide by 2. And then I'm going to do a zoom trig, because that will give me a nice trigonometric window. So a zoom 7. So here's the sine function. And here comes y equals the square root of 2 over 2, and you can see that we have an intersection point here, we have another one here, we have another one here, and we have another one here. And if we open that window, say we change our window from, instead of negative 2 pi to positive 2 pi, say we change it from negative 4 pi to 4 pi. We go back to the graph. So we're going to see more cycles of sine x because we've opened the window a bit. And you can see all these places where the two sides of the equation are equal to each other. So there's really an infinite number of solutions to this, but our job is to find out what those values are, what those values of x are that make the left-hand side equal to the right-hand side. So let's come down and actually solve this algebraically. So this is the same exact equation that we just had, and it says to solve the equation, sine x equals the square root of 2 over 2. So the first thing I want to do is find values from 0 to 2 pi. And we'll do that first. And so in order to find the values where sine of x equals the square root of 2 over 2, I'm going to remind myself that the sine is positive in the first and the second quadrants. The angle whose sine is square root of 2 over 2 is pi over 4. And then I also want the second quadrant angle whose reference angle is pi over 4. And since I know this is 4 pi over 4, that this is going to be 3 pi over 4. So my job is to first basically find how many solutions are in one rotation, or from 0 to 2 pi. So the solutions from 0 to 2 pi are pi over 4 and 3 pi over 4. The next thing we need to do is to find all real solutions. B would be find all solutions on the interval from negative infinity to infinity, or basically find all real solutions to this. I start with the fact that I know x is equal to pi over 4, plus if I rotate around one more time, that's like adding 2 pi, and I could get one solution by going one more rotation. I'd get another solution by rotating again. And so what we do is we say pi over 4 plus 2 pi k, where k is an integer. Right. So this expression will give me almost, we're not there, we don't get all the solutions, but we'll get all the solutions that are coterminal with pi over 4. We're going to do the same thing with the 3 pi over 4. I start with x equals 3 pi over 4, and to find other solutions I'm going to add 2 pi k. And basically k is an integer for both of these expressions. So for part A, for all the solutions from 0 to 2 pi, we get 2 solutions. To get all real solutions for over the real numbers, in other words from negative infinity to infinity, my 2 solutions are x equals pi over 4 plus 2 pi k and 3 pi over 4 plus 2 pi k. In some questions you're going to be asked to give the solutions from 0 to 2 pi, and in other questions you'll be asked to give all real solutions. In some you'll be asked to give both. When we solve more complicated trigonometric equations, there's a short list of steps. But basically your job is to isolate the trigonometric function on one side of the equation and then solve for the variable. And so first thing I'm going to do here is I want to get the sine x on one side. That would be my trig function. And in order to do that, I'm going to subtract 6 sine x from each side, leaving me with negative 2 sine x minus 7 equals negative 6. I'm going to add 7 to each side. Now divide each side by negative 2. So we have sine of x is equal to negative 1/2. And so the first thing I'll do is to find those solutions in one rotation where sine is equal to negative 1/2. And I know that sine is negative in quadrants 3 and 4. The reference angle for when sine is equal to 1/2 is going to be pi over 6. And so we know that this is 6 pi over 6. So this angle right here would be 7 pi over 6. We know this is 12 pi over 6. So this other angle, the fourth quadrant angle, will be 11 pi over 6. So my 2 solutions that are in the first rotation from 0 to 2 pi are x is equal to 7 pi over 6 and 11 pi over 6. I'd like to show you how to check these 2 solutions using your calculator. So what we're going to do, and we should be in radian mode again because our angles are in radians, we're going to go into y equals, and we're going to put the left hand side of the equation in. 4 sine of x minus 7. And then in the second equation we're going to put the y2, we'll put in 6 sine x minus 6. And I'm going to quit out of there. So I know I'm going to get one value on the left hand side, I'm going to evaluate the right hand side. So I'm going to quit out of this, and I'm going to show you how you can pull back those variables. You use the vars. So the vars key, you go over to y vars, and we're focusing on function, and see how they have all of the y sub 1's, y sub 2's listed. Y sub 1 is where the left-hand side of our equation is, and I'm going to evaluate that at 7, you don't need the second key, at 7 second pi divided by 6, and hit enter. And now I'm going to go in to the vars key, go over to y vars, hit enter, and go down and pull up your y2. That I'm going to quit out of that. Sorry, it should be y2. Let's clear that. Go vars over to y vars, hit enter, arrow down, hit enter. So I've pulled up my y sub 2. I'm going to evaluate that at 7 pi divided by 6 and hit enter, and I get the same exact value. So let's go ahead, so we can be sure that the 7 pi over 6 is a solution. Let's go back and evaluate each of these for 11 pi over 6. So we can repeat the process by going into vars and y vars and pull up y1 and y2. So let's do that. We'll go vars, y vars, function, y1, and we'll evaluate this at 11 pi over 6. Hit enter, and then we'll pull up the second y2, which is where our 6 sine x minus 6 is, and we'll evaluate that for 11 pi divided by 6, and we get the same exact value. So this is another strategy that you can use anytime you solve an equation. You can put the left-hand side into one of your y equals functions, and you can put the right-hand side into the other, and then use the vars key to evaluate. This is nice when you want to evaluate more than one solution. Now I want to find my general solutions, and I know that if I go all the way around for one more rotation and keep doing that, I will generate more solutions. So for part B, I start with the 7x equals 7 pi over 6 plus 2 pi k, and k will be an integer. Also, x will equal the 11 pi over 6 plus 2 pi k. And it's important to specify that k is an integer. So at this point, you're done with the problem, but I do want to show you how this whole idea of 2 pi k will generate more solutions. So let's do a hypothetical. Suppose you're asked to list more solutions. What you would do, in order to list more solutions, you would start choosing values for k. And so if you let k equal 0, I think it's a little obvious that when k equals 0, you'd have 2 pi times 0. So you'd get the two original answers. You'd get 7 pi over 6. And when k equaled 0 here, you'd get the 11 pi over 6. So those would be the solutions generated from that value of k. If k equaled 1, we would substitute 1 in for k. We would get 7 pi over 6 plus 2 pi, or 7 pi over 6 plus 12 pi over 6, or just 19 pi over 6. That would be another solution. And the same thing, we'd have 11 pi over 6 plus 2 pi, or 11 pi over 6 plus 12 pi over 6, which is the equivalent, which would give us 23 pi over 6. And so even though this particular question didn't ask you to list more, it just wanted the solutions from 0 to 2 pi, which we gave, and it wanted the general solution. If in the future you're asked to list more solutions, you do that by just using different integer values of k. You could use -1, -2, any integer value.